And so this brings us to our two main quantifiers that we care about. And they have really cool symbols. And these will be the first really cool symbols you guys learn in math that'll make you feel really complicated, like you're in a movie, writing on a whiteboard or writing on a glass or a mirror, where they do in movies. And that is, we're gonna have, let's use colors. The universal quantifier over here, and we'll have the existential quantifier am I spelling existential right? Well, you can't even read what I'm writing, so it doesn't matter. Existential. Is it an S? When did I write this? It's a T.
It's a T, yeah.
Yes, thank you. That's embarrassing. There we go. Existential quantifier over on this side. And I'll use purple to separate them because I know colors. There we go. So, the universal quantifier, this is, we give it a cool symbol. We give it this symbol right here, upside down A is the universal quantifier, and it means for all or for every or for any, things like that. It brings up the concept of saying that for whatever range we're talking about, our things got to work for all of them in there. And it's got to work for each one. Actually, that brings up another good point. We also have for each. Yeah. So that's what universal quantifier is. So for example, if you had the statement, every Hemsworth brother is rich. I originally said handsome, but that's subjective. Rich is kind of more subjective, less subjective. Every Hemsworth brother is rich. Every, here you should be thinking for all. For all the Hemsworth brothers, they are rich. But how can we kind of put this more mathematically? We're saying every Hemsworth brother is rich. So what we're really saying is that for all people that happen to be Hemsworth brothers, they're rich. And so this right here, this is our domain. This is the domain of things we're talking about. Domain equals Hemsworth brothers. Which, if you don't know, are famous brothers, Chris, Liam, and Luke. No one knows Luke, but he's I guess he's like moderately rich. And then is rich, this is like our predicate. We're gonna say P of X is rich. And so this statement can be rewritten as, for all X and D, P of X. Saying, for all people that are Hemsworth brothers, so all people in the set of Hemsworth brothers, they are rich. Does that make sense? Let's do another example. For each n of the natural numbers, n times pi is irrational. You don't even know what any of this means yet, but pi, right, 3.14, the decimal goes on forever, it's irrational. The question is, in pi, like 1 times pi, 2 times pi, 3 times pi, 4 times pi, is that also going to be irrational? But we don't really care what it means right now. We're talking about, can we rewrite it? And notice that this above statement is, I'm going to call it true. All the Hemsworth brothers are rich. The point is, this is a statement. That's a truth value. Let me back down here. So for each n of the natural numbers, in pi is irrational. Let's check this out. So for each n and n, well, this is clearly our domain, right? That's D. N pi is irrational. That's what we're saying about each n and n. The statement we're making is that n pi is irrational. So this is kind of our predicate. So you could call this like q of n, something like that. And then this for each, that quantifies how many things in the domain we're talking about, and that's all of it, the for all. So the way you can rewrite this is that for all n and d, q of n. Does that make sense how this is related to this? Doing all right? We'll have a bunch of examples, so don't worry about it too much.